The Big Crunch. In this scenario, which dates back to 1922, the universe's expansion eventually reverses and the universe would collapse on itself. This is based on the hypothesis that the density of matter is so high that gravitational attraction will surpass the expansion that started with the Big Bang, causing that expansion to stop, with contraction being inevitable. After the collapse, the universe would become a black hole, potentially followed by another Big Bang and the reformation of the universe. This process of expansion and contraction could repeat in an infinite cycle. Experimental evidence, such as the observations of distant supernovas and mapping of the universe, has shown that the expansion of the universe is not being slowed by gravity but is rather accelerating, showing that the Big Crunch is unlikely but not completely ruling it out. The Big Rip. This hypothesizes that all matter in the universe, from stars and galaxies to atoms, is progressively torn apart by the universe's expansion at some point in the future. This relies on a hypothetical form of dark energy known as phantom energy. Regular dark energy, which affects the whole universe, is constant and causes the universe's expansion to accelerate normally. However, phantom energy accelerates as well, which in time will increase the acceleration of the universe's expansion to a speed even faster than light. This increased acceleration would make the observable universe smaller, as galaxies would fly away from each other so fast that they wouldn't be able to see each other. As things rip apart faster than light, the very structure of space-time would no longer be stable, causing the universe to break down. The theory of the Big Rip is supported by uncertain measurements of the strength of dark matter. However, most physicists believe it to be unlikely, as it's unclear how ripping interacts with other laws of physics, and phantom energy wouldn't behave according to normal physics, as it would require negative kinetic energy, which usually doesn't happen in the universe. The Big Bounce. The original expansion of the universe, the Big Bang, is envisioned as being followed by a period of contraction, also known as the previously explained Big Crunch. After this, another Big Bang will occur, which will be the Big Bounce. This suggests that we exist at any point in an infinite sequence of universes, or we could be in the first iteration that would inevitably end and be followed by a new one. The Big Bounce's existence has yet to be fully demonstrated, but various studies involving numerical simulations have confirmed the quality of the theory's features. Heat death. Also known as the Big Freeze or the Big Chill, this is a scenario in which continued expansion of the universe results in it approaching absolute zero temperature. All energy would be evenly distributed and there would be no temperature differences or other processes to perform work, such as the movement of the universe. Stars, such as the sun, would not have any fuel to continue shining and the universe would grow dark and everything would become too cold to support life. This hypothesis would not happen for billions of years and has had opposing views based on how we still don't know enough about the whole universe to make completely accurate predictions. Vacuum decay. The universe is filled by something called the Higgs field, which varies in strength. When the strength is low, the universe is in a state known as a false vacuum, which is not stable. If a part of the false vacuum was decayed or transitioned into a true vacuum, which is stable, what can result is a bubble of the true vacuum expanding in all directions at light speed, which would be lethal as it would incinerate everything. While measurements of the mass of Higgs particles seem to show that the vacuum is unstable, the fact that we're still here indicates that the universe is more stable than calculations have shown, and even then, It is predicted that the lifetime of an unstable universe is much longer than the current age of the universe, and therefore won't happen in the lifetime of humanity. Thanks for watching.